Welcome to Earth Science, the study of our remarkable living planet. For the next 13 minutes, we will take a journey through time and space, from the violent birth of Earth 4.5 billion years ago to the challenges it faces today. This is not just the story of rocks, oceans, or weather. It is the story of home. Imagine the early solar system, a swirling cloud of dust and gas surrounding a newborn sun. Collisions were constant. Tiny grains stuck together, forming pebbles. Pebbles became boulders. Boulders merged into planet-sized worlds. In this chaos, Earth began as a molten sphere of rock and metal. In its first 100 million years, Earth was a dangerous place. Asteroids the size of mountains bombarded the surface. One collision was so massive that it nearly tore the planet apart. A Mars-sized object, which scientists call Theia, slammed into Earth. The debris blasted into space, circling the planet and eventually clumping together to form the Moon. That ancient scar still defines us. The Moon stabilizes Earth's tilt, controls the tides, and has guided life for billions of years. As Earth cooled, heavy metals like iron and nickel sank inward, forming a dense metallic core. Lighter materials floated upward, becoming the crust. Between them lay the mantle, a layer that moves slowly but powerfully over time. Volcanoes erupted everywhere. They released gases, carbon dioxide, nitrogen, and water vapor. This became Earth's first atmosphere, thick and toxic. Rain fell for centuries, filling the basins that became the first oceans. Comets crashing down added even more water. Within these oceans, something extraordinary happened. Life appeared. At first, it was simple, microscopic organisms clinging to vents on the ocean floor. But over billions of years, these microbes transformed the planet. They released oxygen in what scientists call the Great Oxidation Event, turning Earth's skies blue and making complex life possible. This is the stage on which our story unfolds, a planet shaped by fire, water, and time, constantly changing, constantly alive. To understand Earth, we must look beneath our feet. The crust, the outer skin, is thin, just 5 to 40 miles thick. On this fragile shell, all of human civilization exists. Beneath it lies the mantle, nearly 2,000 miles deep. Though solid, it flows slowly, like warm tar. This movement drives the great engine of plate tectonics. Below the mantle is the outer core, a churning sea of molten iron and nickel. Its swirling currents generate Earth's magnetic field, an invisible shield that deflects deadly solar radiation. Without it, life could not survive. At the very center is the inner core, a solid ball of iron, as hot as the sun's surface, yet locked in place by crushing pressure. How do we know all this? Not by digging. We've only drilled about 8 miles down. Instead, scientists use seismic waves from earthquakes. These vibrations travel differently through solid and liquid. By measuring them, geologists can map Earth's hidden interior. The surface of the crust is not fixed. It is broken into enormous slabs called tectonic plates, which float on the moving mantle. They shift only a few inches per year, but over millions of years, this slow motion reshapes the world. Continents drift, oceans open and close. At times in the past, all land masses were joined into a single supercontinent, like Pangaea. Then they tore apart, drifting into the arrangement we see today. In the future, they will move again, creating new mountains and seas. This slow but relentless dance explains why we see mountains, volcanoes, earthquakes, and ocean trenches. Earth's surface is never still. When plates collide, they crumple upward to form mountain ranges. The Himalayas, home to Mount Everest, are still rising as the Indian plate pushes against Asia. Every year, the mountains grow by a fraction of an inch. When plates pull apart, magma rises to fill the gap. Along the mid-Atlantic ridge, new ocean floor forms, pushing continents slowly apart. Some places are far from plate boundaries, yet volcanoes rise anyway. These are hot spots where plumes of magma push upward. The Hawaiian Islands are a chain born from such a hot spot, each island a timestamp of volcanic activity stretching across the Pacific. But with creation comes destruction. Earthquakes strike when plates grind against each other. Stress builds until the crust suddenly shifts, releasing energy that shakes the ground. The San Andreas Fault in California is one of the most famous, a reminder of the power hidden beneath our feet. Volcanoes and earthquakes can devastate human life. In the year 79, Mount Vesuvius buried the Roman city of Pompeii in ash, freezing people in their final moments. In 1883, Krakatoa erupted with such force that it was heard 3,000 miles away, and the ash cooled global temperatures for years. In 2004, a massive earthquake beneath the Indian Ocean triggered a tsunami that killed more than 200,000 people in a single day. Yet these disasters are also evidence of Earth's vitality. Volcanoes build islands. Ash enriches soil, creating fertile farmlands. Earthquakes remind us of the energy locked deep inside a restless planet. Surrounding Earth is a delicate veil, the atmosphere. It is mostly nitrogen and oxygen, with traces of other gases. But its importance is immeasurable. It shields us from space debris, moderates temperature, and creates the weather we depend on. The atmosphere has layers. The troposphere is where we live, where clouds form and storms rage. Above it, the stratosphere contains the ozone layer, which blocks harmful ultraviolet radiation. Higher still, the mesosphere burns up meteors. The thermosphere glows with auroras, where solar winds collide with atmospheric particles. Beyond lies the exosphere, where air fades into space. Weather is the short-term expression of the atmosphere. Winds, rain, and snow shape our daily lives. Climate, however, is the long-term pattern. Together, they are driven by the sun's uneven heating of Earth. Warm air rises at the equator, cool air sinks at the poles, and currents of air and water distribute energy around the globe. This circulation creates storms, hurricanes, and monsoons. A hurricane draws its strength from warm ocean water, spinning into a massive engine of wind and rain. Tornadoes form from violent thunderstorms, their twisting funnels capable of leveling towns in minutes. Climate has shifted many times in Earth's history. Ice ages came and went, shaping landscapes. But today, human activity is altering the climate at an unprecedented pace. Burning fossil fuels adds carbon dioxide, intensifying the greenhouse effect. Glaciers retreat, seas rise, heat waves, floods, and wildfires grow more intense. Understanding the atmosphere is not just science, it is survival. 70% of Earth's surface is covered by oceans, vast reservoirs that regulate temperature and support life. They absorb carbon, store heat, and circulate energy through powerful currents. The water cycle links everything together. Water evaporates from oceans, condenses into clouds, falls as rain or snow, and flows back through rivers and streams. This endless loop shapes landscapes, nourishes crops, and fills reservoirs. Ocean currents like the Gulf Stream carry warm water from the tropics to the north, softening Europe's winters. Changes in these currents, like El Niño and La Niña in the Pacific, trigger droughts, floods, and storms across the world. Beneath the surface, oceans hold mysteries. The Mariana Trench plunges 7 miles deep, darker than night under crushing pressure. Yet life survives there. Strange fish, giant squids, and bacteria that thrive in conditions we once thought impossible. At hydrothermal vents, superheated water bursts from the seafloor, feeding entire ecosystems that rely not on sunlight, but on chemical energy. Oceans are also fragile. Coral reefs, sometimes called the rainforests of the sea, are dying from warming waters and acidification. The Great Barrier Reef, once vibrant with color and life, has suffered mass bleaching events in recent decades. Our oceans are both cradle and mirror. They birthed life and they reflect the health of our planet. Life on Earth is deeply interconnected. Forests release oxygen, wetlands filter water, microbes recycle nutrients. Each species, no matter how small, plays a role in the balance. But human activity is changing that balance. Deforestation clears millions of acres each year. Pollution poisons rivers and skies. Overfishing empties oceans, and greenhouse gases warm the atmosphere. We are now a geological force, reshaping Earth as dramatically as any natural process. Yet, there is hope. Conservation efforts have brought species like the bald eagle and gray wolf back from the brink. International agreements have slowed the destruction of the ozone layer. Renewable energy is growing, offering alternatives to fossil fuels. Earth science gives us the tools to understand our impact and to choose a different path. It teaches that every action has consequences, but also that knowledge brings power, the power to heal, to protect, and to restore. Step back and look at Earth from space, a pale blue dot floating in darkness, the only world we know with oceans, forests, and life. Compared to our neighbors, Earth is extraordinary. Venus is a furnace, its surface hot enough to melt lead. Mars is cold and dry, its rivers long vanished. Among billions of planets, Earth sits in the Goldilocks zone. Not too hot, not too cold, just right for life. The moon steadies our tilt, preventing wild swings in climate. Our magnetic field shields us from solar winds. Our atmosphere nurtures instead of destroying. All of these factors combine to make Earth uniquely habitable, and yet it is fragile. A thin atmosphere, a limited biosphere, a world that can be disrupted by our own actions. The lesson of Earth science is clear. This planet is our only home. Its history is long, its systems complex, but its future depends on us. By studying Earth, we gain not just knowledge, but responsibility. So as we conclude this journey, remember, the ground beneath your feet, the air you breathe, the water you drink, and the sky you see, all are part of one living, changing system. To understand Earth is to understand ourselves. To protect Earth is to protect the future.